The topic of this video is on reflection and rotation symmetry. So reflection symmetry pretty much just means that if I were to fold an image along a line, it would sit on top of itself, right? So, or it would be a complete mirror image of itself. And so this first image has reflection symmetry, because if I fold along this line right here, this triangle is going to sit right exactly on top of itself. The same thing is true for this polygon here, right? If I fold here, this is gonna map to there, etc. Where you start to see this fall apart would be like number 3. In this trapezoid, if I fold along this line, I'm gonna have a little bit of a problem because this is going to kind of like fold back like this. And so it's not gonna sit on top of itself. There's gonna be a chunk missing. So this would be an example of not a line of reflection symmetry. Same thing with this one. Here again, this line is a reflective symmetry here because of that arrow is gonna sit one on top of itself. Where it really starts to really apply to this standard is when we're talking about quadrilaterals. Okay, so what type of quadrilaterals have reflection symmetry? And I'm hoping you're seeing that this parallelogram does not. If you fold anything oblong, it's not going to work. If I fold along this diagonal right here, that's not going to create reflection symmetry. This corner here is going to end up like over here somewhere. Sorry, my artistry is terrible, but like the corner is off. Okay, so it's not going to work. Same thing with the rectangle. Okay, anything oblong like this is not going to create any reflective symmetry. If you don't agree or you're not sure, grab a piece of paper, just any piece of paper, and fold it from corner to corner. You'll notice that these opposite corners, they don't line up, okay? And so the other thing that we like to look at is rotational symmetry. So if I put a point in the middle of this figure, can I spin it on, if I hold my finger right there where that dot is, can I spin it and get this thing to sit right on top of itself without going all the way around 360 degrees? And in this one, I can spin it until it gets to this point, and so that would be one turn. This one I could spin to this one, there's a second turn. This one has 3 turns that I can make before it sets on itself, right? A trapezoid doesn't really have any rotational symmetry. I can't spin it unless I go from this and I go all the way around. It's never gonna sit on top of itself. So this does not have any reflection symmetry, or I'm sorry, rotational symmetry. But a rectangle, right? This one somewhat does, right? If I spin this image and I go 180 degrees, these 2 corners will sit here and here. And then if I spin it another 180 degrees, it'll sit there again. So I think you want to make sure that you say something has rotational symmetry if it needs less than 360 degrees to get around to it, okay? A square, it is nice because of its all equal sides. This definitely has rotational symmetry. Same thing with a rectangle, great rotational symmetry. Parallelogram has rotational symmetry. It's 180 degrees, but it has it, okay? Where this kind of applies to transformations is when it's on a coordinate plane and you're looking at what you can do with these figures, right? Can you reflect over anything or rotate it in a specific way? So here we have a rectangle, which, remember, rectangles do not have any diagonal reflection symmetry, but they do have rotational, okay? So this is asking if they reflect across the y-axis. Well, that's right here, and that's definitely not in the midpoint, so it wouldn't have reflection symmetry in that regard. This next one says, what if I reflected across y equals 3? If you're not sure where that is, just Google it. That comes up. But y equals 3 is 1, 2, 3 is this line right here. And this looks lovely because that's right through. That's not the diagonal. It's right through the center of that rectangle. So this, we would say, is great. If I rotate it 100 degrees around the origin, that's probably not going to work because the origin is, this rectangle is not centered. So the origin is here. So if I do that, it's not going to sit on top of itself. It's going to be down here somewhere. And if I translate it, well, translations aren't going to get something to sit onto itself. This is going to move everything one point to the right. So that this would also not work. So that has reflection symmetry across a random line kind of in the middle. This next one says, which will map this ABCD onto itself. Again, sitting on top of itself like that, rotation or reflectional symmetry. If I reflect across the y-axis, that's right here, that means that this image is going to be over here somewhere, so it's definitely not that one. If I rotate it 180 degrees, it will be the exact same. It'll be over here where this picture is, so it's not that one. And if I reflect over the x-axis, that's going directly through the middle there. That's giving me that reflectional symmetry that I want. A circle, there's lots of things you can do with a circle because a circle has great reflection and rotational symmetry. If I reflect across the x-axis though, that's right here, which that's not through the middle, so that will not work. If I move it up, if I translate it, that also will not create something onto itself. A reflection over the y-axis, if we take a look at that, that y-axis is going through the center of the circle, which is important. It's right there. That definitely is going to get something onto itself. If I rotate it clockwise, it doesn't say through the origin, so then you would imply that it's through the origin. And if I rotate this 90 degrees, it's not going to work. Now, if I rotated it, if it would have said like, if you rotate around 0.0, that would be different because that would work for whatever degrees. But it's not around the center, it's around the origin. And because of that, that makes this not going to work either. Last but not least, my favorite kind of questions are the parallelograms. And I think these definitely confuse students, so be very, very careful. If you reflect over y equals x, that is a diagonal line going right here, okay? And if, again, remember, parallelograms do not have any reflectional diagonal symmetry. So it definitely isn't going to be this one. And it's also not going to be this one, the negative one. So that's still a diagonal line. And they do not have any diagonal symmetry. If you rotate this 90 degrees, if you kind of, that's just moving this corner to, oops, sorry. That's moving this corner here to this corner. And that's also not going to work because this, although it does not look oblong, it is. This is a lot larger than this. So anything that's going to jack that up, that's not going to sit one on top of itself. So a 90-degree rotation is also not going to work. But remember, I can spin this 180 degrees and I would be right on top of where I need to be. So this has rotation symmetry of 180 degrees. I'm hoping that this somewhat helped click. At the end of the day, you can always just actually use your patty paper or your commands to check these to make sure, but you really want to make sure you've got those quadrilaterals down. If you have any questions, don't hesitate.